In this video, we're going to be discussing how to find the domain of a function when we are given the function as an equation. Remember that the domain of a function is made up of all x values that produce a real number output. And some common issues that prevent us from having a real number output are things like dividing by zero and trying to take the square root of a negative number. So these are things that we're going to need to check for when finding the domain. Remember, dividing by zero results in an undefined answer, not a real number output. Trying to take the square root of a negative number results in a not a real answer or an imaginary answer, so that would be not a real number output. So these are some of the pitfalls that we're going to try to avoid. So let's look at our first example here. We have find the domain of each of the following functions, and in A, we are given f of x equals x squared plus 5x, and hopefully from some of our previous discussions, you remember that x squared plus 5x is a polynomial function. And you might even know it's even more specific than that, a quadratic function, but we're more concerned about the fact that it falls under that polynomial umbrella, because the nice thing about polynomial functions is that they all have a domain of all real numbers. So if you can identify your function as a polynomial, whether it's a quadratic, a cubic, or a higher level, you automatically know that the domain is going to be all real numbers and you don't even have to do any calculations. Let's look at B. In B, we have g of x is equal to 3x divided by x squared minus 4. And we're eventually going to learn that this is a rational function. But right now, what we're concerned with is the fact that this function contains division. Remember that dividing by zero is one of the pitfalls that we want to avoid. So we want to make sure that we only allow x values that do not make the denominator equal to zero. So in this case, the numerator doesn't affect the domain, only the denominator. And the denominator, we simply want to make sure that we do not allow it to be zero. So if we set our denominator equal to 0 and solve, then the resulting x values can be excluded from the domain, because remember, what we're solving for here are values of x that make the denominator 0. So those are the values that we cannot include in our domain. So we're going to add 4 to both sides, take the square root of both sides, and remember, when we add the radical, we also have to add the plus or minus. So we end up with x is equal to both positive and negative 2. So that means that our domain has to be everything except positive and negative 2. And so there are a couple different ways that we can write it. In interval notation, we would include everything from negative infinity to negative 2, but we wouldn't include negative 2. Then we would include everything from negative 2 to 2, but we wouldn't include either of those. And then we would include everything that's larger than 2. So we would actually have 3 different intervals all being unioned if we wanted to write it in interval notation. Some students prefer to use set builder notation. And remember that as long as we write the domain in set notation, it doesn't matter what notation we use. The exception to that is that when you're working in MyLabs Math, they will specify the form that they want you to use. So make sure that you use whatever notation they indicate. So we have interval notation. Our other option would be set builder notation. So we would say x such that x is not equal to 2 and x is not equal to negative 2. So either of these would be acceptable ways to express the domain of g of x. In our last example, in C, we have h of t is equal to the square root of 4 minus 3t. Well, remember that in this case, our concern is that we cannot take the square root of a negative number. We can take the square root of 0. We can take the square root of a positive number and get a real number output. But when we try to take the square root of a negative number, we end up with a imaginary answer, not a real number. So our concern here is to make sure that what's underneath the radical, also known as the radicand, is greater than or equal to 0. So I'm going to come to the side. I'm going to set the expression under the radical greater than or equal to 0 and solve, and then that will give me the values of t that I can include in my domain. Now, don't forget that we have to follow our rules here for solving a linear inequality. So we start by subtracting 4 from both sides, and we end up with negative 3t is greater than or equal to negative 4. But when we divide both sides by negative 3 to get the t by itself, don't forget that rules of inequality say that we have to change the direction of the inequality symbol. So we end up with t is less than or equal to negative 4 over negative 3 simplifies into 4/3. So in this case, the values that we get here are what we do include in our domain. So in the case of dividing by 0, we were finding the values to exclude from the domain. When we're finding the domain of a square root, we're actually finding the values to include. So in interval notation, well, t just has to be less than or equal to 4/3. So the low endpoint would be negative infinity. The high endpoint would be 4/3. We never include negative infinity, but because it's equal to, we are going to include 4/3. And then if we wanted to write it in set builder notation, we could do that simply by saying t such that t is less than or equal to 4/3.